Right, okay, so that's the part B of the that series of videos about the implicit differentiation, and I'm gonna work on the B1 part. There's another video that I've explained how the implicit differentiation ends up with a dy over dx, and there's another video for it. So just look for it and just kind of like watch it. Perhaps if implicit differentiation is a bit of a thing for you and you need some help with. So to begin with, it says, for part B, it says find the coordinates of the points where the tangent lines are parallel to the line y equals x. And I thought, and you should be thinking the same way, what is actually this relation that I have there? Is it a relation? Is it a function? What does it look like and how does this work? So what I've done, I just popped into Desmos. And Desmos is a tool you should love, especially if you're doing IB mathematics at 10 level, because it helps you visualize what you're actually dealing with. And of course, we are talking about a relation, not a function, because if you do the vertical line test, then that would cut the black line, which is the representation of the relation we're working with at more than 1 point. Therefore, it fails the vertical line test, and this is where we are with that. So what you can see there is the relation that you're working with and the y equals x, and let's just read the question together so we understand what's going on. We want to find the coordinates of the points where the tangent lines are parallel to the y equals x. This is my y equals x. What the tangent lines are going to be, and I'm going to try to do as much good job as possible. There's going to be one up here, and then there's going to be another one down here, and let's just put it tangent 1, and then tangent 2. And what we want to find is the points. So let's put that point A here and point B here. So what we know is that the line y equals x has a gradient or slope that is equal to 1. Because if you think about the general form of y equals mx plus c, the y equals x, the c is equal to 0, right? And the m is equal to 1, and that's where you end up with the y equals x. So basically, we want to find the points for which dy over dx, right, which is the slope at any point of the relation that I'm working with, it has to be equal to 1. I'm just combining those two. So what I do have is that 2x minus y over x minus 2y, we want this to be equal to 1. Let's cross multiply. 2x minus y, or even better, multiply by x minus 2y both sides. That's going to give you x minus 2y. Now we want to be able to find, we're not going to find an answer like x equals 5 or whatever, but we're going to find the relationship between those 2 points. So let's bring the y's to the left side and the x's to the right side, or anything to the first side. It doesn't really matter. You're going to have to end up separating them eventually, but so don't worry if you cannot see in advance what I'm doing here. So that's going to become 2y minus y is going to be equal to x minus 2x. So that's going to give you y is equal to negative x. So what I get here is that the points of the x squared minus yx plus y squared is equal to 3, who would have tangents that they would be parallel to the y equals x, they are on top of the line y equals minus x, or otherwise the points A and B, there will be points for which they fall into the line y equals x. So let me just draw the y equals x. Let's just zoom in. So you know that this is like the y equals x, then the y equals minus x is going to be the diagonal between the second and the third quadrant, right? and that would be the y equals minus x. That's it. And we want to find the points for which the a and the b, that they are now on top of the y equals minus x. Now, you could kind of by observation assume that these points, they're going to be the -1, 1 and the 1, -1, but you don't want to fall into this sort of category and make some, well, it wouldn't have been a bad assumption, but it would make sense to show algebraically how we reach that example, how we reach that conclusion. So you ended up, so you have x squared minus xy plus y squared is equal to 3, the original equation, that was the number 1. And then we also have that y is equal to -x, and that's number 2. And if we combine those two, or we replace all the y's in 1 with 2, so 1 will become, because of 2, x squared minus x times -x plus -x and all that squared is equal to 3. That's x squared plus another x squared because of those two, plus another x squared because the -x and all that squared become positive is equal here to 3. So you end up with 3x squared is equal to 3. Divide by 3 both sides. That will give you x squared is equal to 1. That means x squared minus 1 is equal to 0. Let's do the right thing, which is to factor. X minus 1 times x plus 1 is equal to 0. And that would give you that x is equal to 1 and x, but y and x again. Very tempted to write y, and x again is equal to -1. So, what do I get? For x is equal to 1, right? The point that I get is going to be the 1, comma, -1, and I know that because I can bring it back into 2 and find out that when x is equal to 1, the y is going to be -1, and that's the point B that I saw on my graph. And then when x is equal to -1, put it back into 2, that would provide you with the y is equal to 1, and that would be point A. And that's it. These are the 2 points that they have tangents. These are the 2 points of the original relation that they have tangents that they're parallel to the y equals x. And that's it for now.